It's very rainy outside and we have nothing. Yeah, you see how it works, guys. No rain inside, guys. Welcome. In this video we're going to build something really interesting. I'm going to use this bike. In the last video it didn't fly, so we're going to use this bike, and the idea is to turn this bike into a sport bike with enclosed cockpit. It's going to be really interesting, so let's start working. It's broken from 4M. Applause. Let me introduce you to our sponsors, HBM Machines, your go-to for all things tools and equipment. HBM Machines, your go-to for all things tools and equipment. They believe the right tool is half the job done, and they've got a massive range at honest prices. Whether you're a pro or a DIY enthusiast, HBM Machines have you covered. Break it down. Music. From workshops to crafting, find everything you need for your projects. Break it down. Check out HBM Machines at their physical stores or online web shop, making it convenient for everyone. Want to explore more? Check the link in the description. Happy crafting. Now we're going to lower the seat position because cockpit going to be not so high now. The SE doesn't fit anymore. I have to cut it. Come made here some reparations. You see it was broken. It's okay. So guys, we're done with back assembling, and now we're going to make some preparers to make the cockpit. We need a vacuum pump, heaters, a big table. Let's do that first. Hello everyone. In today's video, we're going to accelerate so fast we'll outrun the rain itself. The objective of this project, meanwhile in the garage, is to fully transform a high-performance Yamaha YZF-R1 Superbike. A motorcycle cockpit, especially one built to shield the rider from rain, introduces a newly enclosed space around them. The rider's head could strike the roof or windshield, causing the cockpit to feel a bit uncomfortable. The initial task is building a wireframe skeleton which acts as the base for the full cockpit music framework. This framework is built using metal rods combined with chicken wire mesh. The rods are curved and molded to create the rough shape of the roof, offering the essential form and structural integrity. After the wireframe is finished, the next step is covering it with a layer of expanding foam. The foam is sprayed directly onto the chicken wire mesh using a spray applicator for even coverage. As the foam expands, it fills any gaps within the wireframe, forming a solid mass that enhances the structure's overall strength. Once the foam cures, it can be trimmed, molded, and sanded to achieve the desired smoothness and finish. This is where the rough, uneven surface formed by the foam is shaped into a smooth aerodynamic contour. By using manual sanding blocks alongside power tools, the builder carefully removes excess foam. You see a base hole. As we observe, he regularly inspects the structure to ensure it aligns with the intended design. Additionally, the smooth surface created by the filler application will be essential for the later application of a protective coating. To achieve this, something truly unique must be crafted. A heating device specifically designed to evenly distribute heat across polycarbonate. The frame is constructed from square tubular steel bars which are welded together to create a sturdy rectangular base. So is this the next day? The frame needs to be robust enough while also providing proper ventilation and ensuring safety when handling high temperatures. Once the frame is finished, the next step is to install the heating panels securely in place. The heating panels are infrared heaters recognized for their ability to generate consistent controlled heat. To enhance heat distribution, the interior of the frame is lined with reflective insulation made from aluminum foil. Without this insulation, a large portion of heat would escape, causing uneven softening of the polycarbonate sheet. In this regard, the reflective insulation maximizes heat retention, which is essential for achieving precision in vacuum forming. Cables are heat resistant. Now we're going to work on the side. The wiring is meticulously arranged to enable control over each individual heating panel. The control panel enables the operator to fine-tune the heat levels, ensuring the polycarbonate softens evenly across the surface. It's so beautiful, guys. Look at that, man. All heating panels must function properly and the temperature must stay consistent across the entire music surface. Testing ensures that the heating device operates as intended, eliminating any electrical issues or uneven heat distribution. Music. After this, a large polycarbonate sheet destined to serve as the transparent roof is prepared for the next steps. This material is an excellent choice due to its lightweight nature, impact resistance, and heat-resistant properties. Before the heating process begins, the polycarbonate sheet is measured, cut, and firmly secured over the previously constructed music platform. To prevent heat from damaging the expansion foam, an anti-thermal cloth is carefully placed over the top of the mold. The heaters are activated and the chamber starts warming the polycarbonate evenly across the surface. However, polycarbonate must be heated to a precise temperature, typically ranging between 150 degrees Celsius and 160 degrees Celsius to ensure it softens properly without becoming too fragile or too rigid. This is the point where it becomes flexible enough to mold without breaking or compromising its structural integrity. Can you see the bubbles? The softened polycarbonate is placed over the mold and a vacuum is applied to pull the material tightly across its surface. This is a quick and efficient method for creating complex three-dimensional shapes while preserving strength and transparency. Excess material is trimmed away and the edges are sanded smooth to achieve a professional finish. Afterward, the mold is separated to form the walls of the MWIG module. The process is repeated to ensure consistency and efficiency throughout the entire building process. MWIG. The sheet is transferred once more from the heater to the mold, but the transition must be swift to avoid premature cooling. During this stage, it's essential to monitor the vacuum suction to ensure it forms properly around every curve and edge. Finally, the cooling time can vary depending on the polycarbonate's thickness and the surrounding environmental conditions. Patience is key, as removing the polycarbonate too soon while it's still warm could lead to warping or distortion of the MWIG material. The canopy is then trimmed to remove excess material, just as was done with the upper part of the module. MWIG. Aligning the polycarbonate with the frame involves carefully positioning the canopy over the cockpit's metal frame structure. Using alignment tools like clamps and temporary braces helps keep the polycarbonate securely in place during this phase. Clamps ensure the canopy remains in position while it is being MWIG secured, preventing any unwanted shifting during the process. Temporary braces allow the builder to test fit the canopy before finalizing its attachment, ensuring a precise fit. Once the polycarbonate is properly aligned with the metal frame, the next step is to secure the canopy permanently in place. To achieve this, holes are drilled through both the polycarbonate and the metal frame with precision, ensuring a secure fit. In this case, rivets are the preferred option due to their durability and their ability to evenly distribute the load across the joint. As each rivet is installed, the canopy is gradually secured more tightly to the frame, creating a strong and stable connection. However, for areas requiring extra flexibility, such as around moving parts or hinges, a different fastening method may be used to allow for smooth movement. Bolts or screws with washers can be used in these areas to allow for slight movement without loosening the overall MWIG structure. Next, in addition to securing the polycarbonate canopy to the frame, extra metal support brackets are added to enhance stability. As you can see, these brackets are custom made to match the unique contours of both the canopy and the frame for a perfect fit. MWIG. Made from aluminum, these brackets help evenly distribute the load of the canopy across the entire frame, significantly reducing stress. Once shaped, they are carefully placed around the edges of the canopy and secured in place using screws or rivets. These reinforcements are crucial for preserving the structural integrity, particularly during harsh weather conditions. The polycarbonate must be strong enough to endure external pressures without deforming, all while ensuring a safe space for the rider. From this stage onward, the motorcycle must be modified to ensure the cockpit can be installed safely and MWIG securely. Since the cockpit adds significant weight and aerodynamic drag, the existing frame must be reinforced to support the additional load. The builder starts by welding extra support bars to critical areas of the motorcycle chassis for added strength. These support bars are crafted from lightweight yet durable materials such as high-grade steel to prevent adding unnecessary weight. I hope you got it. Custom brackets and mounting points are also designed and fabricated to ensure the cockpit can be securely fastened to the frame. This reinforcement ensures the structural integrity required to support the canopy while maintaining the bike's overall MWIG handling. As mentioned earlier, the cockpit itself must also be aerodynamically efficient to minimize drag and optimize performance. It adds a new surface area that will influence how the bike moves through the air at high speeds, affecting its stability and performance. The seating position must also be adjusted to ensure the rider has ample space and comfort within the cockpit. This also involves adjusting the handlebar height and angle as well as repositioning the foot pegs for optimal comfort and control. To compensate for this, modifications are made to the suspension system, ensuring better stability and handling under the added weight. If the front end becomes too heavy, it can negatively impact steering. Stronger springs and upgraded shock absorbers might be fitted to support the added weight, particularly at the front. Fitting the cockpit also called for electrical adjustments to make sure all systems function, Music, smoothly. This involves wiring for extra lights within the cockpit along with the external, music, lighting. So it's also done. The polycarbonate cockpit is eventually positioned and aligned over the bike. The builder carefully shapes the cockpit to flow with the bike's natural lines, keeping a smooth aerodynamic profile. At this point, exact measurements are made to confirm the cockpit is centered and doesn't obstruct the rear's controls. Music. On the other hand, the overall design of the cockpit significantly influences several of the most critical visibility, music, points. As you can see, the stock rear-view mirrors stick outwards and their usual mounting point would fall within the cockpit's edges. Music. Once the new mirror positions are determined, the stems are either shortened or adjusted to a new mounting location. The mirror stems are replaced with shorter versions to fit neatly and stay out of the cockpit, music, profile. Meanwhile, additional safety modifications are carried out, including ensuring that the cockpit is firmly secured while driving. The reality is that motorcycles are frequently exposed to the mercy of the elements, particularly during heavy rainstorms. Riders encounter reduced visibility, discomfort, and a significantly higher risk of accidents in such conditions. Music. This modification effectively transforms the motorbike, making it suitable for all weather conditions. The cockpit's sleek, curved design minimizes air resistance, helping to ensure the bike stays streamlined and efficient. Additionally, the windshield provides a clearer and broader field of vision free from the obstruction of water droplets. Moreover, the option to integrate windshield wipers, which would further improve visibility, is now on the table for consideration. Additionally, its streamlined design guarantees that the mirrors don't cause unnecessary drag, enhancing both riding comfort and visibility. This project serves as an excellent example of how clever design can completely transform a motorcycle, making it a much more versatile and capable vehicle. By utilizing advanced materials such as polycarbonate, along with innovative modifications to both the structure and aerodynamics, this Yamaha YZF-R1 has been expertly modified to handle rainy conditions while maintaining its high-performance capabilities. What started with the creator's deep passion for airplanes has since evolved into something far more innovative and refined. His extensive experience in mechanical engineering combined with a strong dedication to pushing the limits of vehicle design is clearly evident. Indeed, this motorcycle prototype marks a significant step forward in enhancing the safety and protection of motorcyclists. If you enjoyed this video, be sure to visit Meanwhile in the Garage's channel where you'll discover more incredible projects and innovations.